Security and governance is a top priority for Palette. We approach client considerations with transparency and provide control throughout the application stack and lifecycle management. This begins with where customers want Palette to run in the first place. They can pick from several options: multi-tenant SaaS, with instances available in the USA or in Europe; dedicated SaaS, providing a managed Palette environment entirely for yourself, where you can also pick the desired cloud region to run it from self-hosted, where you can run Palette on your own infrastructure, in your own cloud or on-premises, or self-hosted air-gapped, where the entire platform runs without requiring any access to the internet. This means that all container images used by the platform are available locally. For those who need to comply with Federal Information Processing Standards, Palette Vertex is the Spectro Cloud product that ships with FIPS 140-2 compliant container images. Packs and cluster profiles have indicators on the FIPS-compliant status of a layer. Continuing with visibility and transparency, we publish all security advisories and CVE reports in our documentation in the security bulletins. Contained in the CVE reports, you can find the CVE ID, relevant dates, applicable product versions, component type, severity, and status. Drilling into the CVE, we can see the exact dates, the exact component dependency, NIST summary, and our official summary. Our security advisories are dedicated guidance related to critical CVEs that impacted Palette, how our teams responded to the issue, and our recommendations to clients. Palette is an API-driven platform, and as such, we understand that to approach security intentionally, we must provide comprehensive documentation on our APIs. Our API documentation provides this visibility, including authorization information, request scheme, expected responses, and code snippets. We encourage use of direct API interaction and provide tools and resources such as an SDK, Terraform provider, and Crossplane provider to explore and interact with our APIs. Palette Vertex is easy to install in self-hosted and air-gapped environments. Here we have 3 nodes where the installation ISO has been run. We are linking them together by taking a generated token from the first node and passing it into nodes 2 and 3. In just a moment, the nodes will synchronize. Now we can install a Kubernetes cluster that contains all of the components to run Vertex. We use the embedded configuration and pass in the desired cluster name, Kubernetes pod and service siders. Then we provide a virtual IP address from an available address, add the nodes into the node pool, press complete, and wait for the deployment to finish. Customers who manage self-hosted Palette have the ability to manage tenants as a resource boundary from the system console. Tenants are encrypted separately and do not share data or resources. Here, we are quickly setting up and activating a new tenant from the system console. From within the Palette tenant, we provide additional granular control and permissions boundaries. Most resources and APIs are scoped to either the tenant level or project level. Projects provide isolation so users can be confined to their own resources. Here, we will create a new project. Tenant administrators can set role-based access controls by either leveraging a number of predefined roles or creating their own. Each of these roles consists of a set of permissions at a project scope for project resources, at a tenant scope for tenant resources and permissions, or a resource scope for individual clusters. Permissions are granular and aligned to a create, read, update, and delete model for various APIs at each scope. Roles are assigned to users and teams for access. Here we will create an example user and assign project-level permissions. Next, we'll create a team and assign default permissions for members of that team. When changes are made to resources at a tenant or project level, audit logs are captured and can be viewed, filtered, and exported. For authentication, Palette supports single sign-on with a variety of identity providers. In Palette Enterprise, Google and GitHub can be enabled as third-party identity providers. For Palette Enterprise and Palette Vertex, custom SAML and OIDC providers can be configured. Palette supports SSO identity providers such as ADFS, Entra ID, Okta, Keycloak, and more. OIDC Auth can assign users default permissions based on their groups. Cluster-level OIDC settings can also be inherited from the tenant. Looking at a cluster view now, we click on the Backups tab on the top ribbon. For business continuity and disaster recovery, clusters can be backed up regularly or backed up on a schedule. Cluster-level or namespace-specific backups can be performed, which are then stored at the configured backup location in S3. Once a backup has been taken, restores of entire clusters can be performed to the same cluster or to another cluster with matching CSI drivers. Now, using the Scan tab on the top ribbon from the cluster view, a variety of built-in security scans are available to give cluster administrators information about security baselines and compliance. Kubernetes configuration security scans provide detailed information about the compliance of a cluster to CIS benchmarks. Reports will show high-level pass, fail, or warn for each CIS control against the control plane, worker nodes, or both. Kubernetes penetration testing scans surface configuration issues and any threats related to open ports. Scans can be configured to run against internal API endpoints, external-facing, or a combination of both. Kubernetes conformance scans test the adherence of the cluster to CNCF specifications. Software Bill of Materials, or SBOM scans, generate a list of container images and inspects them for dependencies against a vulnerability database. In addition to the security features built into Palette, security teams can easily build cluster profiles made up of the security tooling needed to secure clusters. Spectro Cloud provides verified and community packs for authentication and authorization, policy as code, cloud-native application protection platforms, runtime security, observability tooling, and more. Spectro Cloud's approach to building cluster profiles as a template made up of the various layers of the cluster means that updates, upgrades, and complete component replacement is as easy as changing a layer in the cluster profile and updating the cluster to use the new cluster profile version.